Probability as a general concept can be defined as the chance of an event occurring, denoted as probability of E. Where do we see probability? In cards, in forecasts, in games, in gambling, in medical fields, and definitely we have other fields where we can see probability. A probability experiment is a chance process that leads to a well-defined results called outcomes. Every single outcome is the result of a single trial of probability experiment. A sample space is a set of all possible outcomes of a probability experiment. Probability is a number greater or equal than 0 and less than or equal than 1. When probability is 0, it means the event is impossible to happen. When it's 50%, there's an even chance for an event to happen. And when it's 100%, it means there is 100% certainty that the event will occur. Examples of sample space. When we roll a die, this is the sample space, the numbers from 1 to 6. These are all the numbers we see on the faces when we roll a die. When we toss a coin, the sample space is head or tail. When we toss two coins, the sample space is head, 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 tail, tail, head, and tail, tail. And when we answer a true, false questions, the sample space is going to be true or false. The sample space for rolling two dice is as such. Note that 1-4 is different than 4-1. This is 4 on the first die and 1 on the first die. So keep this in mind. When we roll two dice, 1-4 is different than 4-1, etc. So we have two dice, we have two faces. This is the sample space for a deck of cards. Classical probability. In classical probability, the events has equally likely outcomes. We have n equally likely outcomes to an experiment. An event consists of a set of outcomes of probability experiment. We have a formula for classical or theoretical probability. So the probability of an event is the number of favorable outcomes, the number of events over the total outcomes, the total number in the sample space. We're going to see the first example. So we have a deck of cards and we're drawing one card out of an ordinary deck of cards. We need to find this probability. The first question is we need to find the probability of getting a king when we draw a card out of deck of cards. So first we need to ask ourselves how many elements, how many items do we have in our sample space? Since the deck of cards has 52 cards, so the number of the sample space is 52. And we have 4 kings out of 52, so the probability of getting a king is going to be 4 out of 52, which is the same as 1/13. When a card is drawn from an ordinary deck of cards, what's the probability of getting a 6 of clubs? Keep in mind, the total number of our sample space is 52, so the probability of getting a 6 of clubs is going to be 1 out of 52. What's the probability of getting a heart? We have 13 hearts out of 52, so the probability of getting a heart is 13 out of 52. So here, the number of the sample space is 52. This is very important. This is the sample space for rolling 2 dice. So we have in our sample space is 36, which is the same as 6 to the power 2. So what's the probability of getting doubles? It's going to be 6 out of 36. So that's 1 over 6. What's the probability of getting a sum of 5? That's 4 out of 36, 1 over 9. When we roll a fair die, what's the probability of getting 3? First, we need to ask ourselves, what is the sample space? So the sample space is the numbers from 1 to 6. So therefore, the probability of getting 3 is 1 out of 6. Now, the probability of getting an even number is 3 out of 6, which is the same as half. The probability of getting a number greater than 4, that's 2 out of 6, which is the same as 1/3. And the probability of getting a number greater than 6, that's 0 out of 6, which is the same as 0. We have a flower that has colored petals, and the petals are congruent. If a petal is selected at random, we need to find this probability, where R represents the red, and capital B represent the blue color, and Y represent the yellow color. So what's the probability of selecting a red petal? We have 3 out of 6. That's the same as half. What's the probability of getting a blue petal? That's 2 out of 6, which is the same as 1/3. What's the probability of getting a red or blue petal? Since here the event has nothing in common, so we can add the two probabilities, 3 over 6 plus 2 over 6, and that's 5 over 6. What's the probability of getting neither red nor blue petal? That's the same as what's the probability of getting a yellow petal? That's 1 over 6. So this is something we're going to tackle in a different video, the probability of OR. So this is the same as 3 over 6 plus 2 over 6. So empirical probability is different than classical probability. In empirical probability, we have frequencies, and the frequency here, to write a probability in empirical probability, we need to write the frequency over the total of frequency, or the sum of frequencies. So if we look at our table here, it represents the blood type of 30 people. So the total of frequencies is 30, and it's also mentioned here. So empirical probability is different than classical probability or theoretical probability. The probability of an event is the frequency over the total, over n, which is the sum of frequencies. So let's see the first example. So if a person is selected at random, what's the probability that this person has blood type A? So the frequency of A is 10 over the total, which is 30. So the probability is going to be 10 over 30, which is 1/3. Has blood type B, so the frequency of B is 8, so that's 8 over 30. Type A or B, so we're just going to add these two. So that's 18 over 30. Type O, that's 7 over 30. And type A minus, since we don't have A minus, that's going to be 0. So that's an example of probability where is 0. Another table where we have males, females with college degrees. So we have 4 types of college degrees: less than 4 years high school, 4 years high school only, less than 4 years of college, and 4 years of college or more. And we have the total of each category, and we need to answer questions accordingly. So this is another example of empirical probability. So in empirical probability, the probability of an event is the frequency over n, which is the sum of frequencies. Now, in our case, the sum of frequencies is 174. This is the sum, this is our n, and whatever we see inside is frequency. Find the probability expressed as a simplified fraction that a randomly selected person has less than 4 years of high school. So it doesn't matter whether he's a male or female, so we're just looking at the category for less than 4 years of high school. So that's going to be 29 out of 174. Another example of a person, regardless of his gender, has 4 years of high school only. That's going to be 56 out of 174. Now, was a female with 4 years of college or more. So we're looking for a female with 4 years of college or more. So we can look at the female, and we need 4 years of college or more. So it's going to be 22 out of 174. With a male with 4 years of college or more, so we have male with 4 years college or more, so it's going to be 23 out of 174. Complement of a probability, the probability of the event plus probability of the complement of the event is always equal to 1. So probability of the event plus probability of the complement is always equal to 1. If we have a jar, suppose we have 4 red marbles or balls, and now we're going to take 5 blue marbles or balls. So the total of the balls is 9. We have 4 red balls, so the probability of selecting a red ball is 4 over 9. And the probability of selecting one blue ball at random is 5 over 9. So notice, if I add these probabilities, is 9 over 9, which is 1. So let's consider the probability of the event is 4 over 9, which is the probability of selecting a red ball at random. And the probability of the complement is 5 over 9. So keep in mind, the probability of the event plus probability of the complement of the event is always equal to 1. So the probability of the blue balls, so the probability of getting a blue ball when one ball is selecting at random is 5 over 9, which is the same as 1 minus the probability of getting a red ball, which is 4 over 9. Another example of a complement of a probability, if the probability that is gonna rain today is 30%. What's the probability that it will not rain today? So if we want the probability that it will not rain today, we're going to tackle this problem using the complement probability. So the probability of not rain is the same as 1 minus probability of it's going to rain. So that's 1 minus 0.3, which is 0.7 or 70%. If we roll a fair die, what's the probability of getting a 3? Let's get back our sample space. So the probability of getting a 3 is 1 over 6. What's the probability of not getting a number 3? That's 5 over 6. Or we can tackle this one as 1 minus 1 over 6, which is the probability of getting a 3. We're taking the complement, and that's the same as 5 over 6. What's the probability of getting a number greater than 4? That's 2 over 6, which is the same as 1/3. What's the probability of getting a number less than or equal than 4? So notice how these two, we have event and we have complement of the event. The same as here, we have the event and we have the complement of the event. So this is going to be 2/3 or 1 minus 1/3, that's 2/3. What's the probability of not getting a red card for a card selected at random? The probability of getting a red card is 26 out of 52. The probability of not getting a red card is going to be 1 minus the probability of the event, which is 26 out of 52, is the same as half. We can also work complement of probability in empirical probability. We have the table where we have the blood type of 30 people and we took their blood type with the frequency. So if a person is selected at random, what's the probability that the person has a blood type AB? That's 3 out of 30, which is 1 over 10. If a person is selected at random, what's the probability that he does not have type AB? I can tackle this two ways. Either I subtract 3 over 30 from 1, or we can add all the blood types except for AB.